We have some really good SubD resources, which I'll show you. But we have some really good resources here on the Rhino 3D website that you can use to then start to help you to understand how this works. So this is an example of a helmet that was designed using SubD and how they've used that. And then they've got some other examples here of other objects. Like I say, it's used quite heavily in the automotive industry. It's used quite a lot in the fashion and jewelry design industry. And obviously architecture is becoming, more prevalent with these more organic shapes. So these tools as well, these little tips, like it's got a gallery of information, but it also has, you can download some models here. So sub-decrease examples, for example, is a good one. And we've got all SubD modeling videos, which are just on here. So it has some really good tutorials on using SubD modeling tools, which can be found here as well.
I'm going to just show you some of the tools that we're going to use to be able to use and create SubD models. So as has been said previously, Rhino is a really versatile piece of software. However, there come limitations when we start to use NURBS services. And I just wanted to quickly share with you some of the different SubD tools. So if we go to the SubD menu over here, we can start to just create some of the different primitives that exist here in SubD. And I'll just show you very quickly some of the primitives that we can use. We can use a 3D face where we can just draw a single 3D face like so. And I can just keep selecting this, but with the certain number of sides that I want, and I hit enter, it will then end. If I click on the tab menu, it will change from unsubdivided mode to subdivided mode, just like so. The next thing that we can look at is some of the other primitives that we have is we have planes. So this will just be a simple plane like so. Again, if I hit tab, I can change from unsubdivided to subdivided mode. And we have boxes. So if I draw a box here, this is a box, and if I hit subdivide, it's going to subdivide this box. We also have spheres, ellipsoids, and cones. Again, if I hit tab, I can unsubdivide it and subdivide it. And quite a popular tool or piece of geometry that is used quite heavily when I create geometry is often I'll start with a torus and then start to manipulate and push and pull this torus into different shapes. So one of the beautiful things once we've created this now is we can start to manipulate this geometry. So I can go to the SubD tools bar. I can turn on and off my filter selections here. And if I want to choose an edge, I can select an edge and I can move this around. If I hit tab again, I can push and pull this edge around. I can do the same with faces. If I choose a face here, and I can push and pull these around. I just have my gumball turned on here. I can also do the same with edges. So I can select a singular edge. I can push and pull the single edge around as well. So if I want to start to add more geometry to a piece of geometry, what I could do is using some of the different tools that are available. If I go to edge mode, for example, and select this edge, what I can begin to do is I can start to extrude this or offset it out. Or I can, if I hold down on the the control key as I'm dragging that out, if I select control, it will drag a new face out. So if I hit control, if I hold control whilst I'm dragging, it will drag out a new face here. And that has just now been created. as a new face. I can do the same command here. If I use the extrude command, which is just here, extrude SubD, I can extrude that edge out. If I turn, it's now constraining it in one direction, so I can change that here. So it's changing it using the UV, a normal direction. It's going in the normal direction right now, which is normal to the surface. And you see that that's what's happening. I can select this edge, and either I can hold control and drag that out, select this edge, or I can use the extrude command. I can change the direction as well if I want to go in the V direction. I can do the same thing. So I can start to manipulate that geometry. I can do the same with faces as well. So I can take these faces, I can just switch the faces on. I can select that, and I can click on extrude, and I can start to extrude these out. Again, I'm just showing you how I can extrude these to create new geometry. And again, I can do the same thing. If I start to extrude it out and hold control, I can start to extrude geometry out. So this way we can start to just push geometry and move it around. And this is how we can create this kind of geometry. If I go with a torus, for example, I can start to push and pull this up and down. And you can see this is how I can start to manipulate some of the SubD surfaces. There are some also other SubD tools like Loft and Sweep, and we have Pipe and Multi-Pipe. And this will allow us to take curved geometry, and we can use it in the same way that we can use some of the surface tools, which is Sweep, and we can use the same here. So for example, if I have just, I'm just going to quickly create two freeform curves. And what I'm going to do is, if I feel like I can't select it, it's usually because my filters are on over here. So I can go to SubD and just turn that off here. And now I should be able to select this. And now if I hold Alt while I drag this out, I can drag a copy out. I can go along here. Okay, and I can take these two surfaces here, these two curves, sorry, and I can go to SubD, and I can do Loft, for example, and I can choose that edge and that edge, and it will create a SubD loft, okay, which is different than a surface loft. So that's a SubD loft. I can do also sweep one rail, where I can take a profile curve. I need a profile curve in order to be able to do this. So what I'm going to do is I'm just going to very quickly go to the curve menu, and I'm going to draw a single line, and I'm going to draw in the front view just so it goes upwards. I'll just draw a single line, and I'll just snap it to the just for that. And what I'm going to do is go to SubD, sweep one rail. You can select the rail and select the sweep shape, press enter, and it will sweep it like so. Again, sweep one rail. You can do sweep two rails. So let's say that this rail is slightly different than the bottom one. We can also go to SubD, sweep two rails, select the first rail, select the second rail, select the sweep profile, and again, we can do sweep two rails. And now these faces are SubD faces, so we can start to manipulate them and push them and pull them around however we want. Just going to turn the filter off again. We're going to go over here. We can also create pipe tools. So if I pipe this, I'm going to select these curves here. Just bear with me. We'll try that again. So SubD, pipe, selects the rail. I'm going to select this rail, and then I can choose my pipe radius, and that will be a SubD pipe. So it creates a pipe, and that's a SubD pipe. If I do a multi-pipe, so let's say, for example, I go to curve, I create just a couple more lines on here, and I now have this network of lines. What I can do is I can go here, SubD, multi-pipe, and it will create a multi-pipe of this. But let's say I want to change the radius so we can see it a little bit better. I'll change it to 5. I'll do it to 10 actually, and press enter. And what this does is it takes a curve network and it creates a multi-pipe around them and starts to create geometry around those curves. So that's the multi-pipe tool. We can also bridge between objects. So for example, if I have this sphere, I'm just going to drag a copy across. What I can do is I can go to the SubD menu. I can go to bridge and I can select one face. And then I select the second face. Sorry, I'll do that again. First face, press enter. Second face, press enter. And what it'll do is you'll see it'll bridge across those two different surfaces. So that's how the bridge command works. You can also fill holes, which works quite well. If I have a hole missing, surface missing, it can go to here and fill, go to SubD and fill, and I can select this edge. And I can just need to select one and press enter, and I can fill that SubD edge in. So that's how the creation commands work. I also have these other tools here. So let's say I want to create sharp edges. I can just turn the edge tool on. If I double click on an edge, it will select the whole edge loop. And if I'm just going to scale this out. So if I hold shift whilst I'm scaling this out, I can start to scale this out here. And what I can do here also is I can use the bevel tool, which will add geometry to this edge. And what that's doing essentially is it's creating a bevel around this singular edge. It will probably work a little bit better. You'll be able to see it better what I'm doing here when I'm in unsubdivided mode. I always model in unsubdivided mode, and that's something that I'll make clear later on. And I'm essentially beveling these edges. Now, if I increase the number of segments to, let's say, 3, you'll see that this edge is now introducing 3 new edges. 1, 2, 3. So 3 new faces around that singular edge. I'm taking that single edge there. If I just turn on the edge, if I double click on it, it'll choose the whole edge loop. And then if I bevel it, and then introducing new geometry around the edge. That's how the bevel command works. If I wanted to crease the edge, I'll show you how that works. I'll just show you this edge here. I'll just do crease one edge. And this is something that's used quite heavily in the automotive industry. So we can do a crease of this edge. And if I do 100%, what it's going to do is it creases this edge. So rather than introducing new geometry, it takes this and sharpens off the edge. So you'll start to see, if I want to get a nicer transition here, and I just crease the edge and do 100%, you're going to see it's going to start to create this crease. If I wanted to just do a portion of the object, like here, if I wanted to just crease this edge here, as it goes round, so it's softer here, but more creased here. What I can do is I can do the crease, type 100 for 100%, and now this is going to get this transition from like a softer edge into a harder edge just around this area. And if I show you very quickly in Arctic mode, you can start to see. In fact, what I'll do, I'll show you in Analyze. I'm going to analyze the surface. And what we'll do is we'll do an environment map. Bear with me, try that again. Try that again. So that's the object, analyze surface, and I'm going to do environment map. And you're going to see, you see that edge as it's softer here, it starts to harden over here. And that's how the crease command works. So these are just some of the basic settings and tools of how to create geometry in SubD and using some of the SubD tools. And this is a more organic way of modeling. So what I'm going to do now is I'm going to jump into some of the more detailed modeling, and I'm going to explain to you some more details about SubD, how it works, and why there's some limitations in NURBS surfaces as well.
NURBS modeling is mathematically calculated geometric surfaces. So, for example, if I was to create a solid sphere, and I just do it center radius, I have this perfectly mathematically calculated geometry here, which is what we call a NURBS surface. And NURBS surfaces, the way that they work, it's a completely mathematically calculated surface that gives us a visual representation of three-dimensional data. Okay, so this is just a normal sphere. If I was to trim away a part of this sphere, which I'm going to do now, if I just quickly show, so I'm just going to create a curve, and I'm going to create a rectangle corner to corner, and I'm just going to trim away this rectangle around this rectangle, and you'll see that I end up with this surface here. So I want you to imagine that I've created a surface that's like this in Rhino. But what you don't see is the original data that was created to make this surface. But it doesn't mean that it doesn't exist. Just because we cannot see it doesn't mean it doesn't exist. So that original sphere is still there. This geometry is being mathematically calculated. So that surface that we see here is being mathematically calculated as part of our sphere. And that's essentially how NURBS surfaces work. So although you can't see the rest of the sphere or the rest of the radius or the rest of the fillet that's happening, it doesn't mean that it's not there. Hopefully that makes a little bit of sense. So this is now what we call a trimmed surface. So it's being trimmed down. And if I want to untrim it, I can type untrim. And in Rhino, we can untrim surfaces and it will bring back my original surface. And so there's a difference between a trimmed surface and an untrimmed surface. But the point that I'm making with regards to this is that Rhino just mathematically calculates lots of different points within space in the X, Y, and Z coordinates, and then it will plot our geometry based upon that. So I'm going to show to you some examples here of some of the different surfaces that we can create. And then I'm going to show you at what point we find limitations with working with NURBS surfaces, and then how we can then use SubDs to overcome those limitations. So for example, what I'm going to just very quickly show you is if I was to create some just very quick curves, I'm just going to create some freeform curves just very quickly. And I'm going to create 1, 2, and then 3. And I'm just going to mirror this over to the other side. I'm going to start at 0. Just going to mirror it over there. And then what I'm going to do, actually, I'm going to just do this another time as well. And I'm just going to bring this down here. So I have these kinds of geometry. Now, the way that NURBS surfaces work exceptionally well is when we're lofting from one surface to another. So, for example, if I was to want to loft from this curve to this curve, it's going to perform that quite well. So I'm just going to type loft, press enter, and I'm going to loft from this curve to this curve, and press enter, and I'm going to go in my perspective view, and then we have this curve. Now, let's just imagine for a second that I might know, but I also want to loft to my third curve. Okay, so how would I overcome this challenge? So if I want to loft to my third curve, if I go loft, I go loft, 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 for example, you're going to see it starts with this one, it ends with this one, and then goes to the next one. It doesn't form this perfect surface. So how can I overcome this? Well, there's a couple of ways that I could do this. I could say, okay, well, if I do a line here at the end of each one, like this, I essentially could then join that together, and I could then do a planar surface on there, and then it would create a surface here. Okay. But what if I want to have a little bit more control over this, for example? Like, what if I wanted to be able to manipulate it so it's not just a planar surface? Because that works quite well when it's a planar surface. But what about when it's not a planar surface? What about when I move these points down, for example, and it's no longer planar? I'm just going to move these points, and I no longer have a planar surface. Okay, how might I overcome this challenge? Well, I could try and use a network surface, which is one of the different surface tools up here. If I go to surface up here, I can use what we call a network surface, curve network, where we can create a curve network. I can say, okay, these are my curves that I want to network, but that didn't work. So I need to explode them first. And let's try it again. So I'll go to surface, curve network, and I could try and do this with these guys. And it says that unable to sort this group of curves, there's a fair chance that the troublesome curves are highlighted, or that the troublesome curves are close to the ones that are highlighted. So these curves are here are causing me a problem. So it doesn't like what it's doing here. Because the way that a network surface works, it works best when it has 3 or 4 different curves. When we start to go into multiple curves beyond that, it starts to struggle to create our network. Okay? I could do a patch surface where I could go, okay, I'm going to take these and I'm going to type patch. I'm going to click OK, and it will patch that surface. But I want to just ask you a very quick question, and maybe you can ascertain it from looking at this. But what is wrong with this surface in terms of if I want to have more control over this surface, thinking about the sphere that I made at the start, what could be problematic about this surface that we see here? Say that again. The solution? The resolution. Yeah, so the resolution, we could lose that. Okay. Well, any other thoughts or ideas? Go ahead. So the UV mapping of it, exactly. So the UV mapping, I can see that the UV mapping right now is running this way. So the UV mapping, it's not running sort of perpendicular to my curves, the UV mapping. It's kind of just following a UV map. And why is it following this type of UV map? Think about the sphere that I made at the start. Why do you think that that's happening? Were you going to say something? So it's not uniform? Yep. And why is it not uniform? What type of surface is it? If you think about the sphere that I made at the start and when I trimmed it. So this is like an untrimmed surface. Yeah, exactly. So this is like a trimmed surface. So it's essentially, if you think about it, this would actually be continuing, this surface would be continuing all the way down. So this is actually just probably a rectangular surface. But what Rhino has done, it's intelligently tried to loft in or patch in our surface for us, and it's only leaving behind where our curves are. Does that make sense to everybody? Okay. But actually underneath this, what we don't see is a rectangular surface that's being trimmed. And that's how Rhino is working. Now, when it comes to UV mapping, as has rightly been pointed out, this can become problematic if we want to have certain UV mapping, or if I want to create more organic forms or have a little bit more control over this. So there's a way that we can overcome that. And this is where using SubD can be really useful. And what I'm going to do very quickly though, I want us to imagine, like, let's say that this here is a surface. Let's say it's a roof of an airport, of a new airport, and we want something to go down the middle as well. You know, so what I could do here is I can start to create, if I just go in the top view, I can start to create more curves if I want to between these. So if I just type offset, what I can do then is I can offset these curves. And if I just increase the amount to like 20, or let's say 12, sorry, that should be okay. And I can do the same on this side and the same on this side, for example. Okay. So now I have this this new curve. So what I can then do is I can loft between these guys here, which is fine. I can loft between this guy and this guy, which is fine. I can loft between this guy and this guy, which is fine. But then when I come back to these, we're going to start having that same issue that we had before. And this is where using SubD can be really useful, because we can start to create geometry. So if you look at the flow of my UV curves now, it's actually starting to improve. So it's starting to get better. I could break this curve up and create sort of a triangle here. So I can go to curve. I'm just going to do a polyline just to demonstrate this. If I go in the top view, I could, at the midpoint of these curves, I could break them up like so. And I could then just loft these guys here. So I could split this curve. I could type split. And then I select my cutting object. And then my other object. Sorry about that. I'll do that again. So, and then I'll do the same over here. I'm just going to select that curve. I'm going to press enter, and I'm going to use that to cut. So now I have these two other curves. So I could try and loft these guys. So I've lofted those. I could try to do the same again down here. So I could take this curve. I could type split. I could select this curve here. And then I can loft between these curves and say, I'm going to loft between this one and this one. Let's say. But can you see that as I'm doing this, although it's doing this, and I end up with this triangle in the center, so I could do a network surface from these, because it's only 3. Let me just do the surface edges. Surface edge. And surface edge. Okay. So I've created the surface. I've managed to accomplish it. But what is the problem, would you say, with this surface? Or what potential problems could you see from this surface that I've created? It's not smooth. So if we want to check how smooth it is, what we could do is we can select the object. I'm just going to join it together so it's all one surface. And up here in Rhino, we can run the Analyze tool. And what we can do is we can analyze our surface, and we could put a zebra on it, for example. And then if I just increase the resolution so it's slightly thinner, you can see how my surface is not very smooth right now. So these zebra lines, what they do is when we run analyze surface and we put these zebra lines on it, it tells us how smooth our surface is. And it gives us an indication how smooth our surface can be. And this right now, what we should have is perfectly running zebra lines that run perfectly smooth over the surface. And right now you can see that this is not a very smooth surface. So that's going to cause problems further down our pipeline, because if we wanted to introduce things like paneling systems to create windows or to openings, this could be problematic. It could be problematic when we come to do materials for the UV mapping. It could be problematic for if we want to 3D print it and it's not quite as smooth as what we want it to be. Or even when it comes to manufacturing, if we were to try and turn this into something that could then be taken to a BIM model that we could then run manufacturing of paneling systems on there, again, it's not going to be ideal. So this is where we can use SubD and it comes into its own when we're dealing with surfaces like this, for example. So to resolve that challenge, what we would need to do is we could start to then play with some of our different SubD tools, and we can start to create a SubD surface, and then we can make the same kind of geometry from this SubD. So I'm just going to go here and I'm going to click on primitive, and I'm just going to put a plane on here. And the way that SubD works is we're working with faces, we're working with edges, and we're working also with points or vertices. Okay. So in the SubD menu, what I have here on the top is this tab where it says SubD tools. And this is what you're going to have open when you're working with SubD tools. And this is where we're going to work with our geometry to improve it. Okay. So let's just take this for example. And what I'm going to do is I'm just going to use this menu bar and I'm going to use these tools up here just to show you where things exist first of all. And then I'm going to show you some tips and tricks that I use that really helps to speed up my SubD workflow. So if I was going to try and create the same type of geometry, if I wanted to create it here, I'm going to use these are our filters here. And what these do is if I click on my filters just down here, and yours might be a little bit further down in Rhino. If I turn these on and select them, can you see what's happening to my filters just here? What it does is if I click on edges, it's going to turn everything off apart from edges. So now all I can select here is edges on my SubD geometry. If I want to select just faces, I click on the faces and what it'll do is it'll turn everything else off and it'll only have faces on. Okay. And now I can move this around. Or if I wanted to do vertices, I can click on that and I can use and move just a vertex. Okay. So this is now my geometry. Now, when I'm working with SubD, what I always do is I always model in unsubdivided mode. So the way that I do that is just hitting tab. So if you create a piece of geometry using SubD and you hit tab, it will go to its unsubdivided mode. SubD stands for subdivided. And what's essentially happening is it's mathematically calculating a subdivision of all these surfaces to increase the resolution, which is something we talked about last week. So if I hit tab, I can turn SubD on and off and the smooth mode. And I typically model not in smooth mode. Okay. Now this is a really important thing to remember, and let me tell you why. Or maybe you can hazard a guess. Why do you think that I model when I'm modeling in a non-subdivided way? And I'd be impressed if anybody knows or anybody has any ideas. Go ahead. Yeah, exactly. So we can sometimes face problems when we model in, if I was to model like this, for example, right now, and I was to just take these edges, for example, and what I'm going to do here is I'm going to just extrude this edge. I'm just going to move it out. Okay. So I can see when it's not subdivided. If I just create something like this, a little bit like this, I'm just going to move that down a little bit. I'm just going to rotate it around. So we have this surface here. When I'm not subdivided, the geometry that I create isn't always, and sometimes when I start to build up more geometry, it's not very accurate, and sometimes vertices can overlap one another in such a way that's not very clean. Whereas when I'm modeling in my non-subdivided mode, I can see where my vertices are in relation to one another in a much clearer way. Let me show you what I mean by that. If I just take this vertex here and I was to move it so close to here, it's like super close to here. When I'm in this mode, you can see that it looks like it's quite far away. But then when I unsubdivide it, I can see that it's actually very close. And in fact, there might be moments where the vertices are actually like so close to one another that it really can become really challenging. But look now, when I've subdivided that, it doesn't face that same problem. Now let's imagine that I was always remaining in subdivided mode. I wouldn't know that how close those vertices were to one another, or sometimes if they're overlapping one another. Yep. So if I go back here and I move this slightly across, you see, it's not showing me that that vertex is just overlapped my other vertex. And if I go a little bit further, you see? So that can sometimes become problematic because if my geometry isn't clean like this, if these vertex now, they're inverted on one another, that can become problematic. So hopefully this makes sense to you. So I typically don't model in subdivided mode. I will do my base meshes or base modeling, not subdivided. And from time to time, I will turn on my subdivided mode by hitting tab and see where I'm at with my geometry. Hopefully that makes sense. It will become more clear as we go through this. Okay, so what I'm going to just demonstrate now very quickly for you is if I just hold this. Let's say I'm creating this same face that I have here. I'm just going to go into non-subdivided mode. And what I'm going to do is I want this vertex. I want it to have more of this kind of shape. So it's so much easier to model in non-subdivided mode because you can get a real good feel for your geometry and how clean the geometry is. And also the massing of the geometry and how it looks. So I'm going to do my big moves here, like when it's like this, let's say. And then I'll hit tab and I'll be able to see where I'm at with the other stuff. Yeah. So I'm going to create this surface here. Now, if I wanted to go up here, I can, if I click here on the on this red cross through the filter, what it will do is it will remove all of my filters. So it will remove all of my SubD filters. So it's really important because what you'll find sometimes, if you've put one of these on, you close that down and you're over here and you're like, why can I not select anything in my Rhino model? Like it's not selecting anything. It might be because your filters are selected and the only things that are selected are curves and edges, for example. And it won't allow you to select anything else in the model. If that's the case, then all you need to do is go to filters over here, check what's checked and what's unchecked. And if you want to just do a really fast way of clearing all the selection filters, so all the selection filters are none, then we can just do that really quick using that button here. Okay? Hopefully that gives you an idea of how we use some of our selection tools for SubD. If I wanted to then select my object, so now I'm in object mode. So when I'm in object mode, I can select the entire object. When I'm in vertex mode, I can always select vertices. When I'm in face mode, I can always select faces. And when I'm in edge mode, I can only select edges. Okay, so if I clear my filter, I can select the entire object. Now, if I run a mirror on here, for example, I'm just going to mirror that really quick. I've got this guy here. And I could mirror it again and just do a mirror down this way. And I can just, I can start to mirror this way. And what I can do is I can just eyeball this and just start to move it around. If you want it to be very accurate, you can make it very accurate, but I'm just going to eyeball this just for the minute, just to give an idea of how I can manipulate this geometry. And now I've created these edges. And now what I can start to do is I can use these as a reference point and I can start to then bridge across this gap. Okay? So what I'm going to do now is I'm going to select this edge, and I'm going to use a function over here, which is called bridge, which is where we can bridge across two different objects. Let me just find it on the menu bar. It's just here. So bridge meshes or SubDs. So I can bridge across those two faces. Now it doesn't work the same way as loft, and I'll explain to you why in just a moment. So I'm going to bridge that and click OK. Now I'm going to select this edge and this edge. And again, I'm going to run the bridge command and I'm going to bridge across. Click OK. Now I'm going to run across here, here, and here. And I'm going to bridge across again. Just there. And now we have the same kind of geometry, but we have this guy left over. So what I need to do here is I need to fill this in. So the way that I would do that again is that if I just go over here and select my correct geometry, fill SubD hole, and press enter. Now I've filled this hole. Now if I click tab, you can see I have this much smoother geometry. And now if I just select this face just very quickly and just pull it up a little bit, I now have this much smoother geometry than what I had before. So if I now run my my command on it, let me just clean this up. And this is where it becomes useful to hit tab, because I can see that this is curved here, but when I look at it here, it doesn't look very nice. So what I need to do is I need to align these edges. So I'll just select the edge mode. I'll select my objects just here. And then what I can do is I can use the scale tool to either scale all these in one direction, or I can go to my edge here and just move this guy, and I can just move it to the point that I'm happy with. If I want to make sure that it stays in the X and Y, what I can do is in the top view, I can do it in the top view, and I can just bring these guys and move them along, and then we have something a little bit cleaner. So I can just bring these and just move them. And the way that SubD works is you're just pushing and pulling edges, essentially. And so I'm going to move this one up. If I wanted them to align perfectly, I could just select all of the edges. And what I could do is I could scale them using this blue. And if I scale them to 0, they'll be perfectly aligned. So if I select this one, and this one, I scale them to 0, they'll all be perfectly aligned. Okay? So now, if I hit tab again, we now have this smooth surface. Now, if I was to do my analysis on this, so if I run my surface analysis, I'm going to do zebra on this one. 1 second. This is an example of where my filter was on, so I couldn't select it. So I'm going to turn the filters off. I'm going to try that again, just for a moment. Just bear with me. And I'll just move this out of the way. I'm going to go to analyze, and what I'm going to do is go to surface, zebra, select this surface, and can you see how perfectly beautiful those zebra lines are? Because now we have a continuous surface that has been created using SubD. So that's just a very fast example about when a SubD would be better to use than a NURBS surface. And it's usually where we have more than 3 faces or more than 2 faces meeting one another. So wherever we have more than 2 faces meeting one another, usually this is where SubD comes into its own. And I'll show you some more examples in a moment. Does anybody have any questions about this? Yeah, sure, go ahead. Sorry, speak up. Yeah. So the difference between a bridge and a loft. So what's happening with when I loft, if I just turn this guy off, when I loft, I'm creating a NURBS surface between 2 surfaces or between 2 curves. So I'm introducing a new surface. Whereas when I bridge, what I'm doing is I'm essentially extending this surface that's here and this surface that's here, and they're kind of merging together. And the only thing that remains is these lines here, which then just become our holding edges. So they're kind of like our UV edges on that singular surface. So we're always working with a singular surface, and these are becoming our UV edges. So it's not the edge of the surface, it's a UV edge within the entire surface. Does that make sense? So this is now one continuous surface, and all these lines is UV edges that allow us to work with it. Okay. Now, one of the rules that I'm going to actually teach you, which is actually really, really critical for SubD modeling, and this is a rule that's critical for whether you're SubD modeling in Rhino, whether you're SubD modeling in Maya, whether you're SubD modeling in Blender. It'll always, this rule is always the same, always, and it derives from the gaming industry, and the gaming industry and the animation and entertainment industry tell us to typically work with quads. Okay, so what is a quad? So if I just go onto my screen here, if I just to hit tab, you see that any surface that has 4 edges is a quad. It's called a quad. But now I want you to look at my example here. There is one surface on there that isn't a quad, and that's a triangular surface. And SubD, typically we tell people to avoid triangles and n-gons if you can, and try to remain with quads. And this basically derives from the animation industry. So for example, when you're modeling something, it can deform much easier as a quad than it can as a triangle. Because if it deforms as a triangle, some of the faces start to create some ugly surfaces with triangles, whereas with quads we can create much smoother surfaces. Does that make sense to everybody? So we always try to model in quads, always. So this is problematic. So if I want to resolve this issue and make these quads instead, I would need to start to introduce some more edge flows in order to make this into a quad rather than into a triangle. And it's a really easy fix. If I wanted to do this, what I can do is I can insert some edge loops. So I can insert an edge loop here, for example, and I can put it in the midpoint. I can insert an edge loop here, and I can put it in the midpoint. I can insert an edge loop here, and I can put it in the midpoint. Let me just do this really quick. I don't like that. I'll just move that across. So now we've got this midpoint. Now what you see is problematic here. We now have an even bigger shape. So it's no longer a 3-sided shape or a 4-sided shape. Anything greater than a 4-sided shape, we call an n-gon. An n-gon. And you can write that down. You can make a note of that. So we work with tris, we work with quads, and when it's a larger number of edges than 4, we call it an n-gon. So this is now an n-gon. I'll give anyone a prize if they can tell me how I can make this into quads. How could I make this into quads? What could I do? So we can move the points. Yeah. So if we were to bring these points together, then we'd have a big quad. And if I was to bring that point again, we'd have big quads. So should I try that? Yeah. So let's try that. So I could bring those points in and merge them together. So what I need to do to be able to do that is we're going to use a command in here. It's called stitch. And what we need to do is we need to take this vertex here and this vertex here, and we need to stitch them together. Yeah. And then we'll just do it in the midpoint. And then the next one we need to do is we need to take this vertex here and this vertex here, and we just stitch those together. Boom. And now we have quads. So now we've just cleaned up our geometry with just like a few moves to create quads. And we'll see how much smoother that looks now than before. Because we have a little bit more control over this geometry. Now we have like this point here, which then makes a much smoother surface. So well done. So that's a really important rule, everybody. So remember that. Please remember that. What happens now is we can see how our geometry flows. So our geometry is now going to flow a certain way. And the only time that it will change its flow of direction is when it hits a point where it can't flow anymore. So what do I mean by that? If I just show you on here, we can see that this edge, it flows like this. So if I was to insert a new edge into here, we see we can do it either up, above or below it. And that geometry is going to flow left to right until the end, and it can't flow anymore. If I was to do the same over here, you can see our geometry flows up and down. If I was to do the same here, our geometry flows up and down. If I was to do it here, You see, this cannot flow. This doesn't flow anymore because it's hit a point here where it doesn't know it. It's like, do I go this way? Do I go this way? Do I go this way? Does that make sense? But when it's just 4, it knows which way, which direction it's going. So now we might need to give it a little bit of help. But if I was to go, okay, well, I want you to go this way, and I was to introduce this, you see what's happening. We're now creating n-gons because that geometry is not flowing because it's like, okay, well, I'm going to create now 2 lines that are going to go down either side. So that will become more apparent as we go through, but it's just a really important principle to understand is about the flow of geometry and how that works. Now we can do big moves. So the other thing is as well, because we're in a low resolution. So what do I mean by low resolution? What do I mean by a low resolution? So if I look at this, I'm saying this is a very low resolution. Yeah, exactly. So the number of faces that we have is very, very low. So if I want to do big moves, I always do them when I'm in low resolution. And when I say big moves, I mean things that are going to have a drastic effect over the overall geometry. Because the geometry only ever can move as far as its next point. So if I was to move this edge upwards, it will only be controlled as far as its next point. So that's a big move. So all of this is going to move. So that's how we can do big moves. So like at Zaha's or Kupimblau, or when we're working with geometry like this, we always stay in a low resolution if we're doing big moves. If we want to start adding more detail, we increase the resolution. So if I want to do big moves, for example, I'm like, well, I want this edge to go up here. I'm going to bring that up, or let's say we want this one to go up. For example, like, okay, we want this one to go up. That's a big move because it's going to control as far as your next point. And now if I hit tab, I can see that that big move has now manifested itself over here. And let's say it's like, okay, I want to also bring this guy up because this is going to be my entrance or whatever. So this airport, I'm going to bring this guy up here. And then, I've created these big moves. Okay. So the more resolution that I introduce, the less control, the less area that is controlled. So if I was to bring a control point here, for example, if I was to bring an edge here, let's say, I'm just going to do it here. And I was to introduce an edge here, I'm just going to introduce another one there. If you watch what happens now when I move those same faces that I was moving earlier, if I just stay in tab, you see it's only moving as far as the next point. So I'm going to have less control over this. So I'm moving just this area. You see? Because I've introduced that holding edge, that edge that is now going to stop my geometry from going any further. And we can work with that. Okay? Does that make sense to everybody? So that's how the resolution works. That's how the geometry works. So that's just a very, very quick introduction to how we can do that. Okay, so one of the things that I want you to do now is I want you to have a go yourself at starting to try and create the geometry that I just created. So what I'm going to do now is I'm going to go over here to where it says SubD, and I'm going to click on primitive, and I'm going to click a plane. And where it says X and Y count, I'm going to turn that back to 1. And the Y count, I also want to be 1. And what I can now do is I can draw a singular surface here, let's say. And that is now a singular plane, a SubD plane that we can work with. Okay? So now, what I can now do, once I've done this, I can turn on the control point, which will bring on the control points in the corner. So this is my SubD surface. I can turn on the control points, will turn the control points in the corner. I can move that to 0. So now I've created this guy here. Okay. And then what we can do is we can just move this edge down a little bit. And what we can now do is we can array. We can take this guy here that we've created. We turn off these. We can either array these around, or what I'm actually going to show you to do is the same way that I did the last one, where I created a surface and then we started to bridge them together. I'll show you how to do that. So if I wanted to take this edge here, I just took this control point here and brought it to 0. If I want to take this edge here, and let's say I want to extrude it out, what I can do is I can hit control as I'm dragging out an edge, and it will allow me to drag a new face out, a new surface. Okay, so let me just show you how to do that. So if I turn gumball on, I go to my edge selection, and I select my edge. If I hold control as I'm moving my gumball, it will drag out a new face from the edge. If I let go of control, it will no longer drag it out. I can do that again, or I could use the extrude command, which is just here, extrude SubD. I can either extrude it, but what this does is it extrudes in the normal directions of the object. So the X, Y, and Z, essentially, it will move in one of those directions. What the other option allows us to do, it allows us to select an edge, and then I can use my gumball, which is here, and constrain it to X and Y using this little square here. And if I hold control, I've got free reign of where I can move that in the X and Y. So let's say I want to move it over here. I can then move it over there, for example. Okay. And if I want to just move my control points, I can do. I can just bring these over here, and I can just move those control points. So once we've got that created, what we can then do is we can just move it away from the midpoint a little bit. And then if I was to use the array command now, what it would do in a similar way as before, it would array those objects around the center point. So if I move this away ever so slightly from the center point, so it was there, if I just move it away from the center point a little bit here, and then I do array polar again, and I select this object, and I set 0 for the midpoint, the center point. I do 3 items. It's now going to array this around 3 times. Okay? Does that make sense to everybody? And then what I can do is I can either do the same thing as before where I bridge across these guys, or I could stitch them as well. So I could take these control points here. I can go over here I can select these 2 control points here, and I can select stitch. And what it'll do is allow me to just stitch those together. So I could do that. But I'm also going to show you how to do the bridge again, because I want to just demonstrate the commands. Or I can make sure my edge filter is turned on. I can select the 2 different edges by holding shift. And then I can go over here to the bridge command, and it will bridge across those 2 faces. Okay? But the problem with doing it that way, if I do the bridge, I'm going to be left with this triangle again in the center, which isn't a problem. But ideally, what I could do is I could just select these edges. I could select that vertex, sorry, and that vertex, and I can stitch them together, and I can just find the average. Again, I can do that here. What's the fast way to hit enter? What's the fast way? Right click your mouse. Remember? So I taught you that last week. The fastest way to hit enter when you're using Rhino, so you don't have to take your hand off the mouse, is to hit right click 1 time. If you hit right click again, it repeats your last command, which is really useful. So if I want to repeat my last command, I hit right click or I hit enter, boom, it'll repeat my last command. So I can then select my vertices again. So I'm going to select, oh, this time I'm going to select my vertices. I'm going to hit right click. I'm going to move it. I'm going to select my vertices. I'm going to hit right click. I'm going to move it. I'm going to select my vertices, hit right click, and then I move it. And now I have this face here. And I can move it around, you know, till I'm happy with where it goes. And now if I hit tab, it'll show me this face. So I've created this guy. And I can delete away my lines that I was showing you the polar array on, just because they were just used as references. And then I can just start to move this guy up a little bit. And, you know, if you want to move these as well, we can move those up. Okay? And then let's say I want to move this guy. Again, I'll create this surface. Yeah? Any questions about that? Has everyone been able to do that? Do you want me to give you about 5 minutes just to do it and I'll come around and help people? Also, anyone on the video, if you're doing it at home, please feel free to have a play around with that now. And feel free to just follow the same process that I followed, where I took these surfaces, I arrayed them, and then with tab, I just stitched them together. So I selected my vertices, I hit stitch, and then I just stitched them together. And then I did the same again. So I'm just going to give you a couple of minutes just to play around with that. And I'll come around and help anybody that might be struggling. Okay, if anyone's struggling or if anyone needs any help, put your hand up and I'll come around. Yeah. Hopefully you've been able to have a quick play around with that just very quickly. And you've been able to create the surfaces. But again, if we just if we want to bring these together, we just hit the stitch and we can bring our control points together. That's how we can manipulate when we're working with control points. But there's other ways that we can work with SubD. And one is we can turn Rhino surfaces into SubD surfaces, and we can turn meshes also into SubD surfaces. Okay, so we could take Rhino surfaces. So we could take these Rhino surfaces, for example. I'll just turn these off. I'm going to select these Rhino surfaces here. And I could do type SubD. Sorry, to SubD. And I can turn any of these surfaces into a SubD surface. And if you'll see now what's happened, well, why don't we just use these outside ones? So I'm just going to select this. I'm going to select just these outside ones like that. And I'm just going to do cell last, which is going to select the last created objects. And I've been able to turn those faces, those Rhino NURBS surfaces into a SubD face now. So now what I could do with these, now that I've created them, is I can do the same again. I can practice doing some of my bridging. So I could bridge across these different faces. So I could go to my edges and I could select this edge and this edge, for example, and I could bridge. And now it's bridging them across. We can also select multiple faces. So if I select 3, but we always need to have the same amount of faces on each side. And if I bridge, now I was able to bridge across. So I could do the same again here. So I was able to take a Rhino surface and make it into a SubD surface and then use that geometry to then start to play around with these guys. I'll just do this. We need to make sure it has the same number of faces, otherwise it won't work. So 1, 2, 3, 4, 5, 2, 3, 4, 5. Try that again. Doesn't like it. So let's try this again. I'll do them one at a time. There we go. That was better. Didn't like the other one for some reason. I'm not sure why. Didn't like those ones. There could be a reason that that's happening. It might be something simple, like there might be multiple faces there, or there might be multiple edges, or there might not be enough edges. But if that's the case, then what we might need to do is we can do some other. We could try to figure another way of creating this out. So, for example, we could try to stitch. If I created, let's see if this works. So these guys aren't working for some reason. Edge loop. Yeah, so it doesn't like it. So what I could do in this instance, um, there's a couple of different things that I could try. I could do append faces to SubD, and what this allows me to do is take an edge and just literally draw a SubD face like so. And what that command there was is append faces to SubD. So if my bridge isn't working and I need to just fill a face in rather than using fill, I can use what we call append. So I can like literally just draw the face out. So if I click on append faces to SubD, again, I select the object and I just select each corner that I want to create that face on and press enter. It's then allowed me to create that singular face. That's called append SubD face. Um, there's another little thing that I want to show you as well. We can also work with meshes. So let's say, for example, that I took this guy and I made it into a mesh. I'll make it into a mesh. And so let's say this is a mesh right now. I can also take meshes that I bring in and then I can do again to SubD. I can select this face and then give me my subdivision options. And it's now created one SubD face using the geometry that I had. And what's happening right now is it's just directly taking the mesh and making SubD faces out of it. Now, what's problematic about me directly making this mesh into a SubD surface? What do you see that could be problematic about me making this mesh straight into SubD surfaces? So it's not made out of quads. Yeah. So what it's introduced for us is quads. Some things are quads, some things are tris. I don't really see any n-gons, but it's possible that anything that's an n-gon, they'll just triangulate anyway. So if it was an n-gon, they'll just triangulate it to make it into tris. So that's a problem. So the only way that you could fix that is we can take this, and there's a command called quadrangulate mesh. And what that does is it allows us to select the mesh and quadrangulate it. And what that essentially is doing is it's taking the mesh and making it into quads as best as it can. Let's see. Yeah, planarity. And I might need to increase the amount in order for this to work in the best possible way. Let's see. Let me just do this really quick. Let me just turn this to a mesh really quick. I'm going to reduce the amount of mesh faces on this one. I'm going to do fewer polygons. Let's just do that again. I'm going to reduce the subdivision level, fewer polygons. Okay. And then let's see if I can mesh. Let's see if I can quadrangulate. In fact, what I'm going to do is I'm not going to quadrangulate. I'm going to quad remesh it. This is what I need to do. So I'm going to take this. I'm going to do a quad remesh, which is just here. And then allow me to do a quad remesh of this face. And what it's now done is it's taken that triangulated mesh and it's done a quad remesh for me. Now this is quite a high resolution remesh. If I wanted like a lower resolution, I just need to play with the settings here. So let's say I want like 100 quads. I'll just try with 100 and see what it spits out for me. And you'll see that it's now created something that's a little bit closer to what I wanted. Let's see if I can do even less and say let's try like 12 and see what it spits out for us. But what I'm essentially doing is I'm taking those tries, I'm making them into quads, ready for me then to bring into SubD to then work within SubD. So it doesn't like that one. So I'm going to try that again. I'll try 24, see if it works a little bit better. So it's just generating the quad remesh. So it's really important that we're working with quads as much as we can. So now, yeah, you see that it's created this. So if there's certain parts that I don't really like, I could start to play around with them and clean this up. We might need to do some quad cleanup if our quad's not very good, or it's not very clean quad. But another thing that you could do is we know that this is how this is. If I was to do a pen to polygon, and if I was to just take this guy, take one of these guys, I could essentially start to draw my polygons out over the top of here if I knew what this looked like. So I can also use this as reference geometry to then start to draw my SubD faces. Does that make sense? So I can also just do an append to polygon and I can use this as a reference point for just like drawing this out. And then I can do append to polygon again. I can do this guy here. And then I will do it to that point there. Press enter. And then I could do the same again. Select this. Point, point. Use that as a point and then go there. And then I can do the same again. And I'm going to use this. I'm just going to just keep appending it until I'm happy with it, with the shape that I've created. And then just keep drawing out exactly what it is that I want, using this as a reference geometry. So there's just a few different ways that you can use the SubD tool to start to create like more organic forms. And I've just like then done that. So I've shown you a few different ways of being able to work with that SubD there. There's one other thing that I want to show you, which is something that's really useful, is once I've got my SubD, I can then thicken it. So I can take the SubD, I can offset it. So I could take this SubD here, for example, or any of the ones that I've created. Let's take this one, for example, and I can offset the SubD. And what that allows me to do is to start to apply thickness to my SubD. Now, when you're doing this, it's really important that you're careful how you do it, because as soon as you apply thickness, you're now no longer dealing with a surface. And what's the difference between a surface and a solid? Do you remember? We talked about that last week. But what is the difference between a surface and a solid? Say that again. Watertight. Good, you remember. Well done. So one of them is watertight. So it's like it's self-contained. The surface is infinitely thin. It has no thickness. It has no thickness. As soon as we do an offset, we've now introduced thickness. We've also introduced more geometry. And I'll show you what that looks like in a moment when I offset this. So if let's say I was to offset this, and I'm just going to type 3, for example, press enter. You see that I've offset this surface and now it's a singular surface. Now, if I was to offset it and turn the solid to on, to yes, it would offset it and make it solid. Okay. If I was to offset this and both sides, what it will do is it will thicken on both sides. If I was to offset this and delete the input, it will delete the original input. But let's say that I offset it like so. I'm not going to do both sides. And I've offset it like this now. What I can now do is what this has actually done, it's creased these edges here. So it's now created new geometry. So if I hit my tab, you'll see that's the undivided version. This is the subdivided version. But you see that this edge is now creased. So it's not like smooth. It's like got a creased edge. So if I was to go here and just play with this guy, we can move that up and down. But now it has a crease on it. You see this edge? It shows me what is creased and what isn't creased. And it will show me that this edge is now creased already. So because this is a creased edge, that's the only thing about adding thickness. What it does is it creases the edges as you start to add thickness. If I wanted to avoid that, instead of offsetting the surface, what I would need to do is extrude it instead. Okay, so I would need to take these faces, for example, and if I was to extrude it, what it does is it will start to add thickness, but where it's created that rim, you see, it's no longer, it's introducing new geometry, but it's allowed me to maintain that curvature that I wanted. Unless, of course, I want to crease it. If you want that Zaha sort of effect, they use creases a lot. So what they would typically do is they'll take an edge like this and we'll apply a crease to it. And then you can say, you know, the amount that you want to crease it, 100%, for example. And let me just do that again. And you'll see now when I turn this to rendered mode, I don't know if you can see it very well there. Let's just try this again. I'm just going to turn this. I'm just going to go back to shaded. I'm going to just do analyze, surface, environment map. And then what we'll do is we'll turn this guy on. And you'll see that that crease that's now appeared. You see? So just by putting that crease on that edge, it will blend the crease and it will go, I did it at 100% there. So it was added that sort of creased edge just to this part, and then it starts to soften back to this edge over here. Now they use this technique a lot in automotive design, so car panels. You'll typically see this kind of thing in car panels, so where they'll have a crease that will then soften itself into another panel. And this is a technique that is used in some of the more organic architectural designs, things like what Zaha Hadid's will do, or Mad, or you know, UN Studio or Cooper Blau, and they'll start to then bring this technique in. So that's how we can start to then add creases to our geometry, but that's also how we can thicken. Now, once we've actually extruded our line, it's started to create new geometry. So you can see now I've got this new edge that has been created. But you'll see that although I've extruded it, it doesn't have thickness. It doesn't have thickness. So for example, if I wanted to make it have thickness, again, I could use the extrude command again for that. And then this time you'll see, because I introduced that new edge, it's now created thickness, but because I created that softer edge on here, that when it does create the thickness, it allows me to maintain this softer edge. So hopefully that makes sense. So you can feel free to play around with this. So you can manipulate your geometry. You can push it, you can pull it. And this is just like modeling clay. It's like digital clay, essentially. You can push things up. You can move that up a little bit. Let's say we want to like have that more pronounced crease just here. We can push it. And we can start to really play around with the geometry that we create. And you have the freedom and the license to sort of do whatever you want with that. Always remember what I said earlier. So look how awkward this object or shape looks now when I unsubdivide it. And that's because I've been doing a lot of my moves when it was subdivided. So if I unsubdivide it and just see that something is like way off, I can start to just play around with it and just make sure that it looks and feels right geometrically in the unsubdivided before I then subdivide it, and then I can start to play around with it again. So that's just an idea of how you can then thicken your geometry using SubD, and how you can also play around with different ways of creasing edges. Okay, creases. Let's say, for example, I'm going to show you another tool now. And let's say, for example, I have some lines and I want to create a bridge or something, with lots of lines on it that I want to then put SubDs around lines. The way SubD works is it allows us also to create lines that we can then apply SubDs around. So let me show you what I mean by that. So I'm going to create a freeform curve, and I'm just going to draw a couple of different curves really quick. So if this was like a bridge network or a network of geometry, okay, so I can create lines like what you see here, and I can use what we call the multi-pipe tool, which is a way of being able to use SubD. Let me just reduce the resolution of this. I'm just going to bring it down a little bit so you can see a little bit better. I'll just zoom in. And I'm just going to move this. So what I can also do, I can take these lines, I can run the multi-pipe command, and it will start to put SubDs around my curves. I'm going to increase the radius to 5, just so you can see a little bit better. And if I press enter, you see what it's been able to do. It's created SubDs around my curves. So let me give you another example where this could be useful. For example, if you're creating like a pavilion or something, and you wanted to play around with this, or if you're creating like a pipe network or an urban design project where you want to create some kind of bridging network, this is a way you can very quickly create SubDs around curves. Or let's say, for example, you were modeling a chair, and you just were, well, let's take this really quick. I'm just gonna do a freeform curve. Control points. Yeah, I'll do a control points curve. I'm just going to do it really fast for you just to demonstrate. Okay, I'm going to take this. I'm going to move it up. I'm going to move it that way. I'm going to take this guy here. And I'm going to move this up. So let's say, for example, this was like, I don't know, some kind of chair framework. And then let's say I wanted to then create some curves that went across. So I could create curves also that went from one side to the other. So I could go to here, curve. I can do freeform control points. And what I'm going to do is in the top view, I'm just going to very quickly just draw a few curves. And then for example, um, let's say I move those up. I'm just going to move these guys to here. In fact, I'll just leave them there for the minute just to demonstrate this. And then if I do the multi-pipe tool, I can then decrease the thickness of this to make it like 2, for example. And I can start to create like more organic forms from what I've created. And then what I could do is I could go back to my SubD tools. I could take the faces. I could start to like push and pull certain parts out, let's say. I can like bring them in and start to like bring them down a little bit, maybe. You know, you can start to then play around with this and create your own sort of organic forms from this idea. And then let's say we wanted to then bridge this together. We could go to bridge and then click OK. And then let's bridge this guy to this guy. And I'm going to go to SubD tools. I'm going to bridge. And then I can then start to move this down. And I'll just rotate it. I'll bring this one down. And I can rotate it. And, you know, you can start to play around with this and push and pull. And create different forms, you know, interesting forms of chairs or, you know, things that you want to create. So that's an idea of how I can use the multi-pipe tool to go around curves that I can then start working into using some of my other commands like bridge or stitching. And I can just start to pull and push and pull and manipulate this geometry. And then let's say I'm like, okay, I want to create sort of like a Voronoi effect down here. So I'm going to go select these guys and I'm going to bridge them together. And I'll do the same over here. But this time I'll go up there. And then, you know, I can then start to play around with this and start to create whatever sort of effects that I want. Okay? Does anyone have any questions about the multi-pipe tool? Yeah, go ahead. So what I did is if I just deselect this for a moment. So if I've got my curves here, if I go into here, if I type multi-pipe, and press enter, now it's going to ask for your curve selection. So one of the rules in Rhino that I reiterated last week and that I'll always reiterate in every session is if you follow what it asks you on the command line, typically you'll never go wrong. So if you just are struggling to know what to do next, just look at the command line up here at the top and it'll ask you or tell you what it wants. So it'll say select curves to pipe. So we're going to select all the curves that we want to pipe and we're going to press enter when done. Okay, so now we can specify the radius and we can specify also the cap and see if we want to cap it, we can either cap it or not cap it. If we cap it, what it will do is it will cap off the ends and create this cap. Okay, so I had a student last year that used this principle for their design project for urban design. And then they started to play around with these spaces and push and pull and create some, you know, more interesting spaces in between. And started to just play around with what they could do with the multi-pipe tool. If I tab this now, we can see that my geometry is inverted. So you see how I'm getting this like funky geometry happening here? If I go into this mode, I can see the reason that this is happening is because this is inverting in on itself. So I don't want that to happen. So I always model unsubdivided first, so I can make sure that my geometry is clean. Because clean geometry is worth its weight in gold, I'm telling you. Clean geometry is everything when you're doing SubD. And that's the same in Maya, it's the same in Blender, and it's the same in SubD. Always, always, always have clean geometry. Because it will really help you in the long run. When you're coming to do either plans from it, when you're coming to either do 3D prints from it, clean geometry is really, really important. So I can't reiterate that enough. So yeah, that just gives you an example of what we've been able to do there. So you see, so yeah, I've been able to, the multi-pipe tool, that's how we do that. So multi-pipe. And I remember doing a project many, many years ago, for my own undergraduate degree, where I used the multi-pipe tool to inform a skyscraper that I designed. And I just created a network of curves, and I was then able to multi-pipe them and then play with that geometry. So it's also an iterative process where sometimes you might go forwards to then come back and then work into it a little bit more and then go back again. So for example, if I was working with this and I wanted to create some openings, for example, if I just go in here into my unsubdivided mode, what I could potentially do is I could select these faces, and there's a command here. Well, what I could do is I could either extrude them, sorry. If I wanted to extrude them, what I could do is I can start to extrude them inwards, for example, and then I could then take the faces that I've extruded and delete them. And now if I go back to tab mode, you see that I've been able to create like these openings now in my facade. And I can then use that as part of my way of creating openings in what I want to do. If I wanted to flatten these guys out, what I could do, I could say, okay, I'm going to take that whole curve network and I'm going to move it upwards so it's more like a platform or more human, let's say, for human interaction or human intervention. And you can just start to play around and push and pull this as much as you want. And remember what I said last week, be experimental, play around. You have nothing to lose at all in playing around and being experimental. Just play with it, do it, save it, close it, start again. You're not doing any harm to anybody by playing around. The key is, though, is not to learn bad habits. And so if you reinforce the good habits from the outset, that'll be really important. So the way that I did that, if you want me to just repeat that again, just hit tab. I just selected the faces that I wanted to delete away. But in order to, rather than just deleting them away, if I was just to hit delete right now and tab, I now have created like a big opening here. So there's no holding edge. I need to create a holding edge. Do you remember geometry always gets manipulated as far as the next control point? So remember that. So by just deleting it away, I've gotten rid of my control point. So now my geometry is going from this point here, this point on this edge here, and the next edge is all the way over here. So we've got all that geometry that we're working with that is now being manipulated by just those two control points. So instead of doing that, what I'll do is I will extrude it instead and introduce some more geometry to create a holding edge so that when I then delete it away, I have that holding edge that's going to retain some of my original shape. Does that make sense to everybody? That's really important. Okay? And we can start to play around with different pattern networks. I mean, you could create, we could create something that was like, let's say, for example, I could take this. I'm just going to delete these guys really quick. What I'm going to do is I'm going to just create. In fact, what I'll do is I'll keep this guy here. I'm going to manipulate it to get the shape that I want and do my big moves. Remember, the lower the resolution of my geometry, the bigger the moves are going to be. So I'm going to create like this canopy or this pavilion. And then what I'm going to do, I'm going to take this geometry here and I'm going to subdivide it. So if I subdivide this, watch what happens. If I subdivide this, it starts to introduce more edges. You see that? It starts to introduce more edges. So what I could then do is extract this wireframe. So I could extract the wireframe from this. Press enter. And now I've got the curves from this. And now I could run the multi-pipe tool, for example, and create a multi-pipe of that structure just by using those curves. So now I've got like the canopy and I've got now a structure, and I could even then combine them and put this back over here. And I've got like now a canopy and a structure just from those really fast moves. So that's just showing you very quickly how you can create some SubD, use it as reference geometry to then create new SubDs and then really create an iterative workflow. And you can play around with that however you want. That's just an example of how you could do it. But when it was low resolution, I could do big moves. If I try to do big moves now, it's going to be much harder for me to do that because this is quite high resolution. So it's only going to manipulate what's going on there. Okay, so that's an example of how you could use that for your own objects. I mean, we could even do the same over here. We could take this guy over here and we could say, okay, I'm going to copy it. I'm going to extract the wireframe from this. And then I'm going to do a multi-pipe. But I need to make sure that it's a smaller resolution, for example. And now you see I've created this like more interesting effect by just increasing the resolution, by playing around with the things that I've created. And I can then just play with it to my heart's content. Okay, so for the last 10 minutes, I'll take any questions that anybody has. Has this been useful? Does it make sense to you? This is the most important thing. So could you tell me what the difference then between like NURBS surfaces are and SubD from what we've discussed today? What would you say the major differences are between NURBS and SubD? Go ahead. Yeah, say it out loud. Don't be shy. Yeah, so the UV mapping is really important. That's a really important aspect of the differentiation between NURBS and SubDs. Definitely. Anything else? Yeah, exactly. Yeah. So if you need a little bit more freedom and you want to play around with it, and also it's a form of design process, because the tools that we use will often limit how we design. So how we design will be informed by the tools that we're going to ultimately use. So if you know a tool really well, you can know what you can do with that tool. If you don't know it too well, and I see this a lot with Grasshopper, people get designed into a box where they go, I can only design this type of thing, therefore you're limited to your skill set. So the more you play with this, the more that you become skilled in these areas, the better your design process is going to be, because you're going to really know as an artist what you can do with the tool that you have. And you don't want to be limited by the tool. You don't want the tool to be the limitation to your design and say, I can only design this because I only know how to do that. The options are endless of what we can create using these tools. But it's ultimately down to you to really push yourself now and learn them to know how you can then go even further with it. And you really can. You can do some really cool, exciting, experimental things as you increase your skill set with the tools. Well, great. Thank you for that comment. Did anyone else want to ask anything or add anything? Any other questions? Yeah, go ahead. If the zebras are closer together, do you mean? Yeah. So if the zebra lines are closer together at some points in the model, so for example, around a vertex, sometimes, let's just do it on here, for example. Let's analyze surface, zebra. So like there might be certain areas where it's like much closer together. I know that it was the case, maybe the case over here. Let's have a look. I know there was a couple of vertexes, and what tends to happen is it's either where the geometry is starting to manipulate, in some way, or it could just be if I just increase the size of that. It could just be like a bug sometimes. But I mean, this is actually not too bad. This is okay. But yeah, there were certain points where you see it starts to get really close together. But you can see that this is just like super, super clean geometry. But yeah, sometimes it might be where there's a big differentiation in the turn in the geometry. That's usually when the zebra starts to behave, in a non-uniform way. When either it's changed, and sometimes we can take vertices, and you can actually, it's called beveling. We can bevel a vertex, and sometimes what that will do is when I move that vertex, it will actually make the geometry behave differently. So you've got to make sure as well that you're not beveling vertices, because that can also change the flow of the geometry. So hopefully that makes sense. But yeah, but you'll come across anything that any issues that you've got, or but yeah, any other questions about this? I'll just check the chat and see if there's any questions in here. No, I think we're good. Yeah, so SubD is used when you want to model something that you cannot model easily with NURBS surfaces. Okay, if you're doing platonic geometry, I don't recommend that you use SubD. When I say platonic geometry, I'm talking about spheres, mathematical spheres. I'm talking about boxes or rectangles or things that are just like you can otherwise achieve with platonic geometry. Only use SubD where you reach the limits of what NURBS can do, and you now need to introduce a new tool that will take your work even further. Okay, and it's usually with organic forms. Hopefully that has been useful for you in how you can start to, build organic forms, how you can use SubD in this way. And I'm really excited to see what kind of things you come up with, what kind of things you play with.